Good morning. 9 weeks test coming up next Tuesday. Test Bank B in the Media Center. Presented to you by the county. One of the first questions that you'll find on the test deals with the ability of a student to make a logical next step. This happened in an experiment, and kind of an intuitive moment, and go ahead and make a logical statement that just feels right. You know, if I had two cans of tennis balls, one's brand new, one's not so new, open up the new can of tennis balls, click the little top, psh, up went the pressure, open up the old can of tennis balls, no, psh, you know, just nothing. Just open up the top, I got two balls. I could say, you know, I think that the ones from the new can will bounce higher than the ones from the old can. So I've made kind of a next step logical statement. It's called an inference, and that be that. The next question, early question on the 9 weeks test, discusses a water molecule. And you should know that the chemical formula for water is H2O. So H2, that's two hydrogens, the O is the oxygen. So I got two hydrogen atoms and one oxygen atom. And they form bonds. They do. And I've got behind me a nice little picture of a water molecule. And something strange, not strange, but something that's a big property of water. And you've noticed it. Water likes water. Water molecules like each other. And you may say, why? And you know, here's the answer. When they bond up, the hydrogen molecules are on one side gripping a much larger oxygen molecule. And what happens, it gets to be kind of like a battery. It's called polarity. So on the hydrogen side, you get a bit of a positive charge, and on the oxygen side, you get a negative charge. Now, this is real handy when two of them get together. Do you see how positive, negative, then that positive, negative, then that positive, negative? And that's why they will link up. Why they'll link up, and that's called polarity of a water molecule, and that gives it an additional property of like adhesion, because it's almost like little Velcro sticky pads when they find each other like that. The next question deals with properties of water again, and it deals with the ability of certain insects and how they are able to walk on water. And so I looked it up, you know, and I looked at their answers and stuff like that. And so I come up with this website. It talks about the cohesive forces between the liquid molecules are responsible for the phenomenon known as surface tension. So one of the properties, like in the previous little blip, you know, the positive side and there's a negative side to the water molecule, and they link up, forming those bonds by their electrical charges. And so as they stick together, as they are cohesive to one another, along can skip an insect running on the water, and it's like, well, why don't you sink? Well, when it comes to the weight, their downward force is not enough to break that cohesive property of the water molecule. This next question deals with your knowledge of monomers and how they get put together into polymers. So it's like units, a repeating unit, and you repeat the unit, and then you make the entire structure. I hope that helps a little bit. Like with DNA molecule, if you look at DNA molecule, you'll notice there's a repeating unit that follows the same structure. They're banded together, and the monomer there for a DNA molecule would be a nucleotide. A nucleotide turns out to be a sugar, a phosphate, and a nitrogen base. So the question kind of asks about the macromolecules and wants you to be aware of what their small parts are before you get to the big parts. So, you know, one would be nucleotides make up DNA. That's okay. The nucleotide repeating unit. Another is an amino acid makes up a protein, because amino acid is the small repeating part making up a protein. Another one is like little sugars, simple sugars. They make up starches. And so this is just basically about the biological macromolecules being made up of their repeating units. This next question deals with proteins and what are they good for. You will find that proteins build structures. They build chemicals. Now those chemicals may be real important when it comes to digestion, become real important to building structures, and they'll become real important when it comes to maybe packaging. As a cell, the Golgi bodies, if you remember, the proteins get built by the endoplasmic reticulum, and then the Golgi bodies do the packaging and the transmission of them. And last but not least, a very important one, proteins act as enzymes. Enzymes end up controlling the rate of reactions that must occur inside the living cell so that life can be sustained. Speaking about substances that go ahead and speed up reactions, of course, in the biological world, we call those enzymes. It's a protein. It's built by the cell to cause these chemical reactions to occur on a timely basis. But if you are away from biological activity, you would call them catalysts. C-A-T-A-L-Y-S-T. All right, got to talk about ATP. I mean, we are talking about cells. The cells need to be powered. The powering of the cells means energy is available for the cell to do all of those activities that promote life. Be it cellular reproduction, protein synthesis, making proteins, amino acids into proteins, duplicating the DNA, maybe growing, maybe the cell's got to grow, maybe it's got to repair something. Well, all that is considered cellular work. And so you got to take your imagination a little bit, and you've got to realize that work does occur at the cellular level, but it needs to be powered by something. Well, this is a very handy-dandy molecule that is available in the cytoplasm. That is it's like a bank. When there's energy available, it'll build this molecule at the higher end. That's this side. Do you see the little bond right there? And when it needs the energy, when the cell needs the energy, it can reverse that and go back to this state, which is adenosine diphosphate with a free phosphate, and energy is out. So let me go back over this real quick. When energy is available, when energy needs to be stored, when the cell wants to make a deposit in the bank of energy, it will take this molecule here. It will take its friendly little phosphate that's free. It's like a little kid in a swimming pool. He's on the little raft, And when energy comes in, it can raise the energy level of this phosphate, so it will make a bond. It will make a bond and actually hook up to the adenosine diphosphate, and that becomes the adenosine triphosphate. Think of it this way. Take a bicycle. You want to go to the top of the hill? You got to push it up to the top of the hill. Does that take energy? Yes. But do you get the choice of when you want to release the energy by taking your foot off the pavement and going down the hill? Yes, you do. You do. So the cell does the same thing. When energy is available, like when it's taking glucose and it's breaking it down through that multi-step process, it will build up these ATPs from ADPs, di means 2, tri means 3, from adenosine diphosphates to adenosine triphosphate. So it builds this molecule, sits in the cytoplasm, ready to go, around the mitochondria, remember, powerhouse of the cell. And then when the energy is needed, it can use an enzyme to break that bond there. It'll go back here, but look, energy is out. So the battery is working, see? And the cell needs it. Like all energy things. Think about your car. You got a tank of gasoline. That's great. Do you want all that energy to be released at the same time? No, your car will blow up. So there's all kinds of systems on your car for releasing the energy under control when you need it. Well, this is the system And it's a molecular system, so don't let that beat you up. We're talking about cells. It's a molecular system for storing and releasing energy in an appropriate manner.